exists, resident students and teachers. Thank you. Sit down. In our last lesson, we were looking at friction. We have found out that friction is a force that slows down or prevents movement. And friction occurs when two objects come into contact from different directions with different speed. So that's what we have found out about friction. We will still look at friction, lesson number 2. And these are some of the things that we will have to do in this lesson. We will observe how friction occurs in different surfaces. And we will describe and measure friction. Our problem to solve is this. How does friction help things to move? There is a question, a problem to us that we will try to find a solution or answer to that. We have 3 toy cars. We brought wind-up cars. You have 3 different surfaces there, which are your tracks to allow the cars to move. So this is what you are going to do. Your instructions. Number 1, have 3 toy cars on 3 different kinds of surface. There is the track. You start them off and time how long it takes to reach the finishing line. Right? So you will start them off and you will have to time them, see how long will one reach the finishing line. So you have a starting line and finishing line there. As you are doing this activity, always refer back to the problem that was given to you. What is the problem again? How does friction help things to move? That is what we are looking at or trying to find out. This is the table that you will have to complete. Fill in your result table and then discuss the reasons for timing of each car. All right? We have A, B, C, D. In this case, we have only 3 cars, so we will have A, B, and C. All right? A, B, and C. So let's say A will be the blue one, the blue car. B will be the orange car, and C will be the green. Now for the tracks, put car A on the track that has glue been stick on. B on the masonite board, and C on the plain paper, right, on that surface. So your instruction is you've got to wind up the car, right? And you set your time, your clock, you wind up the car, right? I think 3 people will have to wind it up until it comes to an end where you cannot wind anymore. And someone will have to hold it by the tire and put that on the starting line, right? So 3 people will be able to do that. And you try to let them go. All right? For the start, I'll let you practice letting the cars run on the tracks. So you've got just about a minute to practice. All right, are we ready? Now listen to these instructions. This side button is for reset. We have start and stop. Now the readings on this big clock here, it's the second, and we have minutes in there. So this is in seconds, right? So that's what you're going to do. You will have to arrange yourself. 3 people will start the cast. 3 people will look at the time. All right. One must be assigned to one cast and one car and take the timing of that car. Okay, you can try that 3 times and get your average time. All right, if you're finished, you complete the table. Okay, quickly complete this information there. Okay. One, it depends on, yes, okay, how you produce the energy in the end. Okay. Now, how much force is being produced in here. The other is the surface. All right, after you get your results, I would like you to discuss the differences between the surface and the vehicle and how long it took. Why is that this car was the fastest? Why is that this one was not so fast on the surface? Why? Right? I believe you have completed your tables. You will also answer these questions. All right, I'd like you to discuss your results quickly. All right, look up to the screen. We have 3 questions here. Which can reach the finishing line in a short time? We'll have group 1 to tell us. And even question 2, 3. Just answer the questions. And we'll have from different groups too. Okay, Tanabek will tell the class of the findings.
Kabi reached the line faster than the others.
And which car reached the finishing line in a longer time? So which of the track provides a good surface for the car to move freely?
Service B.
The track,
B.
the surface that
Yeah.
the Masonite board has.
Yep.
Okay, it has a rough surface. All right, let's have the other group. Which car reached the finishing line in a short time and which car in a longer time? And which track is a good surface?
Car B.
And which finished the reach the line, finishing line in a longer time?
Car A.
All right. Which of the track provides a good surface?
Cardboard.
All right. I think the same result from group 1. Huh? We'll have the last group here. Which car reached the finishing line in a short time?
Car C.
And which car reached the finishing line in a longer time?
Car A.
Which of the track provides a good surface for the car to move freely?
C. The
C.
smooth paper.
The smooth paper. All right. So these 2 groups have a different answer to the other group. Now quickly describe and discuss the surfaces. There are 3 different surfaces. One is rough, one is smooth, the other one is, I think it's also rough. But which one do you think can make a good move? All right, let's have this group to tell us their reason. Why do they think that that's a good surface? You others get ready. You have to give us your reason.
We think that because it's smooth, there's no grip. The type of the car won't have any grip on the paper.
Okay, that's what they think. Good. We'll have this group to tell us what they think.
We think the second surface provides a good road for the toys because I think the tire can grip easily on the board.
Okay, that's what they think. Let's have the other group to tell us their reason.
Ours is B. We think that because it's rough and it's also a solid surface, that's why the tire gripped it properly.
Okay, good reasons. I'll give you a situation here. You think of this situation. You walk into a very new building and the floor is really vanished. The surface is really smooth. What do you think is going to happen when you're walking in? Huh? Is there any chances of you falling? Yes. Why? So is it easy for you to move around? Move freely? Okay, look at the surfaces. All right, in this case, we have seen that the rough surfaces produce a good friction. And for movement to take place, it's very good on a rough surface, right? Because it can haul you instead of you falling off, instead of the car. So for the toy cars, for them to move faster, when you place them on a rough surface, the points in there stick onto the tire, moving the car or the vehicle to move so fast, right? And it's good for it. Now, for surfaces that are smooth, sometimes you will see the tires will just spin on the spot because the surfaces are smooth. There's not much friction in there. Now, for your own work, I'd like you to copy these questions down. Receiving teachers, you can get these questions down for your class too. Question number 1, how would you reduce friction in the following? Bearings in a bicycle wheel, door inches, pulling a canoe from the water onto land, or pulling a post to a river bank. Now, there are advantages and disadvantages of friction. In some cases, friction is good. It's helpful. In some cases, friction is bad, right? But this is some questions, situations where you are asked to give a reason or way how you could reduce friction in these situations. All right, I hope you have got these questions down quickly. You can complete them at your own time. Our summary, there are 3 types of friction. One, we have rolling, sliding, and fluid friction. Let me give you an example of rolling. You can see the surface of the board and the tire of the vehicle. What actually happening is the tire is rolling onto the surface. So there is an example of a rolling friction. If we talk about sliding, how many of you have seen a canoe traveling through the water? All right. In fact, the canoe is sliding through. So that's the surface in there is the water and the canoe. So there is sliding friction taking place in there. And also there is fluid friction between the water and the canoe. So those are examples of the 3 types of friction. Friction force opposes motion. Friction goes against the direction of motion. So that's the second summary point. Our next summary point, friction occurs because of the surfaces in contact. Right? friction occurs because of the surface in contact. When there is no contact of the surface, then there is no friction. Quickly get that down. All right. Our key phrase for today's lesson is friction on surfaces. Our next lesson topic is still on friction, lesson number 3. The materials to bring: engine oil, paint, bucket of water, shampoo, Omo solution, rags, stopwatch, cooking oil, floor mat, canvas, or plastic. If you have big leaves, you can bring banana leaves or taro leaves. If you have them, please bring them. And we'll have a tilted surface. So those are some things that you will have to bring for the next lesson. With that, thank you, HCS, teachers and students, for your participation.